Let us look at the basics of 7-segment displays. You should have seen 7-segment displays in weighing machines and other instruments wherein numbers are displayed. So these 7 segments come in handy when you want to display numbers in a bright way on a whole lot of equipments, projects, and so many things. Today we'll be seeing how we could go ahead and interface a 7-segment display with any microcontroller. Let us go ahead and look at the basics of what 7 segments are and how we could possibly use them. Now, 7 segments, they come in various sizes. By sizes I mean as you see here, they come from 0.28 inches to 7 inches. So 7 inches is a very large size, and they also come in various colors: red, green, yellow, orange, blue, and white. So basically 7 segments, each of the segment in a 7 segment corresponds to a light emitting diode inside. Now this is how a 7 segment looks. So it has 5 pins on 2 sides. So there are total 10 pins, and out of the total 10 pins, the 7 pins correspond to the 7 segments here, and these are A, B, C, D, E, F, and G. So these are the primary 7 segments, and there is also a decimal point. Now this decimal point is used in cases where you want to display something like this, like say you want to display a weight. So that weight, if it is 7.8 kgs, then this decimal point is used. So whenever we have multiple segments, we use the decimal point in those cases. So basically one more thing you could observe is the pins are not aligned in a symmetric way. So it is not like A, B, C, D, and so on. It is if this is the top side of this 7 segment, then the first pin is G, F, and there is a common pin, and then there is A, B, C, D, E, and this is the decimal point, and then again there is a common pin. So what we have is there are 7 pins for the 7 segments, there is 1 pin for the decimal point, and there are 2 common pins. Now we'll go ahead and look at what these are. And basically 7 segments, they come in 2 packages. One is called the common anode and the other is called the common cathode, as you could see here. Now the common cathode or the common anode, these actually are 2 pins on the package, and we need to limit the current that flows, so that we need to place a resistor in between these pins whenever we interface it with a microcontroller. But the point here is for the common cathode, so this pin is eventually connected to ground. So what that basically means is, this is connected through a resistor to ground. So what that means is, whenever we give a logic 1 or 5 volts, a particular segment glows, and since these are arranged in the fashion we saw earlier, we are able to display digits 0 to 9 and sometimes letters A, B, C, D, E, and F. So usually it is used to display just the numbers. So, and likewise, so in the common cathode, when we give a logic 1 or 5 volts, it glows. Similarly, for common anode, this pin is connected to VCC, or let us say that this is 5 volts, and each of the LED, it is forward biased when when we give a logic 0 or ground this pin. So in common anode, the LED or the segment turns on whenever we give a logic 0. So this is the basics of it. So we'll go ahead and look at how we could use the 7 segment to display digits from 0 to 9. Now this is the arrangement of the 7 segments. Now what we have is the segments A, B, C, D, E, F and G, and then the decimal point. And we'll also write the hexadecimal code of the binary pattern that will generate here, because this is helpful when interfacing it with any of the controllers. Now let us go ahead and say we want to display the number 0. So in order to display the number 0, what you could observe is this should be turned on, P should be turned on, C should be turned on, D, E and F as well. Only the segment G and the decimal point need not turn on. And if you assume that this is a common cathode type of display, so we know that whenever we give a logic 1, the segment turns on. So in this case, we need to turn on all the segments except the segment G and the decimal point. So this would be 0, 0, and all other segments would be 1. And it is often useful to write this pattern in hex. So that would be, so this higher nibble would be F and the lower nibble would be C. So that makes the code as 0xFC in hexadecimal. Now similarly, so this is for the digit 0. If you want to go ahead and display the digit 1, only the segments B and C are turned on. Now in order to do that, we just need to give 2 segments B and C, and the other segments would be 0. And if you write the hexadecimal pattern for this, this would be 0, 0, 1, 0, which is 6, and this is 0. So this is 0x60. Similarly, you could draw the patterns for 2, and then this is 3. So you could do 4 in this way, possibly, yeah, and this is 5. So you just need to figure out what needs to be turned on, and that segment needs to be 1. So it's pretty simple. In fact, it's the after the LEDs, this is the most appropriate thing for you to try out. Similarly, you could do for 8. This is how you display the number 8, and this is how you display the number 9. So depending on whether you're using common cathode or common anode, you need to know whether making it logic 1 turns on the segment, or sending a logic 0 turns on the segment. So in common cathode, sending a logic 1 turns on the segment, and this is how you can calculate the bit patterns, and this is how you could interface it with the controller. Thank you for watching.